Hello, hi everyone. I'm Amit M. Aman, and I'm a technical account specialist at Autodesk. I'm a civil engineer with a focus area specifically to construction. I'm joined by my co-speakers, David Mack, who is a construction tech manager at the Walsh Group, and Jeremy Wallen, who is strategic alliances and partnerships manager at Autodesk. Today, we'll be talking about a topic, effortless no-code automation, how you can integrate APIs with ACC Connect for custom solutions. So in today's agenda, we'll first try to cover the problem statement, how you can seamlessly access the data using different web APIs. We'll also talk about introduction to ACC Connect, how it can be used to create integrated workflows. We also have a real world example, how the Walsh Group used ACC Connect to save 100 plus hours of manual effort. And at the end, we'll be talking about what are some of the ACC Connect features that you can leverage in your automated workflow. And that includes some of the demo videos which we have recorded so that you can achieve something similar to what we have done. So moving ahead, first, let me summarize the problem statement. So keeping multiple systems up to date at the same time, it is one of the problems at the moment. So we have multiple systems capturing different kinds of information like ERP systems, CRM applications. Now, how do you keep multiple systems up to date at the same time? The other problem is how you can fetch the latest data without browsing the UI. At times, you may need automated solutions which require you to get the metadata from the UI or the design data from the UI. Do you need to go to the page, go to the portal, download it every time, or fetch that UI, and then probably embed it or consume it within your reporting systems or within any consuming application? So that is a challenge at the moment. The next challenge is a shift towards cloud platforms and growing data accessibility through the APIs. So you're seeing a lot of different cloud platforms which are being rolled out. So we see Office 365, you see cloud platforms like ACC, BIM 360. So there is a shift towards cloud platforms. And how can you access the data readily through the growing set of APIs that are being rolled out? So leveraging the APIs require a connected workflow, and that further requires a development resources. So how do you leverage solutions which can help you build solutions without even requiring development resources? So these are some of the problem statements that I thought of covering at the beginning of the slide so that we can realize what is the value that the solution offers. Now, before I move on to the API aspect, I'd like to cover in very simple terms, what is an API? Now consider that you visit a restaurant and you are the customer. So you make the order, a waiter accepts your order, he takes your order to the chef. Now the waiter, once the order has been prepared, he brings it from the kitchen and delivers the order to you. The same analogy applies to APIs as well. Instead, here we have an end user with browser who is making a request to the API. So the API can serve as a waiter here. And we have a server backend systems, which takes the request from the API, consolidates that information, and passes on to the API, which is then further passed on to the end user with the browser. So if you're into the ACC platform, now you can think that when you're browsing to a particular folder and you're getting a list of files, how is that working? So it is actually leveraging the APIs, which is interacting with the server and returning that information which is shown on the UI. So that is a simple explanation of API. If we get into the definition, the API receives the request from the client and sends back the responses. Web APIs are widely used to integrate the different systems, enabling functionalities like accessing third-party services, retrieving real-time data, and enabling interoperability between applications. To give you a set of APIs that are available, I'll quickly talk about Autodesk Platform Services. So Autodesk Platform Services is a set of APIs which are provided by Autodesk so that you can connect your design and make data with enterprise data. So what are the different enterprise data that are possible, or what are the integrations which are possible with other enterprise systems? So if you want to integrate it with Google Drive or SharePoint, or it could be Salesforce or Power BI. So how do you integrate your design and make data to these systems? So you can do that through the Autodesk Platform Services. So the Autodesk Platform Services APIs consists of various APIs like the Data Management API, Viewer API, which are the core APIs. We also have the data APIs like the AC Data Model APIs, Data Exchange APIs, Model Derivative APIs, and we have the product APIs, which are specific to different products like ACC APIs, BIM 360 APIs, Tandem APIs. So this is a generic example of Autodesk Platform Services, but the rule applies across any third-party API platform that is provided by any third-party provider. Now, how does a sample API documentation look like? So the structure, so the page may look a bit different for different APIs, but the structure remains the same. So you have an endpoint. So you can see there is an endpoint available here. You get a scope, you get the data format, you also get what is the body structure. So what are the different fields, matrices that you need to provide, or what are the different limits you need to set and offset, and you need to provide a token. So this is a generic API documentation. I'm taking the case of Autodesk Platform Services, but it remains consistent across third-party platforms as well. So there are different elements within these requests which are shown on the documentation. So you get the HTTP verb, endpoint, the different query parameters based on the different filters that you'd like to place, and header and body, depending on what is the requirement of the API. So that was a quick overview of how does an API look like, and we'll simplify it in terms of ACC Connect to share how easy it is to set up different automated workflows in ACC Connect. Now, before I move on to the next set of slides, I would like to quickly cover an example. Now, what are the ingredients of a good recipe? So you're planning to have a good recipe prepared, and what are the different ingredients that you'd need so that you can make it a good one and a tasty one? So you need quality ingredients, you need a balance of flavor, you need proper seasoning, you need a texture variety so that it looks great. You need to adopt appropriate cooking techniques. You need to have precise measurements of the different elements, very clear instructions, a visual appeal, and a nutritional balance. So that is what makes up a good recipe. Now, similarly, what are the ingredients of an automation platform? You need to have integration capabilities. You need to have workflow management, an easy interface to use for the end user. It should be having different security features so that the data is securely managed. It should be scalable. It should support the reporting and analytics so that you can have an overview of the different operations which are running, and you could resolve them faster if there are any errors. How do you handle different types of errors? It should support the error handling capabilities, customization options. It should have API access, and there should be elaborate documentation and support available for a platform so that you can readily use these platforms for automating a workflow. So keeping these slides in mind, we'll move on to the solution part, and then I'll come back to the slide again to discuss what are the key capabilities that are available in the solution. So let me pass on to my co-speaker, Jeremy, to cover the solution part.
Thank you so much. And hey, everybody, it's great to be here today. My name is Jeremy Wallen. I work on the AEC integration partner team. So our team works with our vast ecosystem of integration partners to build out integrations for various Autodesk tools. We also manage ACC Connect, or Autodesk Construction Cloud Connect, which is an integration platform as a service that's powered by Workato. So today, just want to give a brief introduction to ACC Connect and how you can use it in your own workflows. But before that, though, just taking a quick step back. Again, we work on the AEC integration partner team. And today we have over 400 different integrations that are built by over 280 partners to Autodesk Construction Cloud. And of course, there are limitless ways to work with your data and integrate your data via ACC Connect. And our ecosystem as a whole, and again, over 400 different integrations from 280 partners, allow you to work with the data from other systems that you may be using on the job site, whether you're in the office or in the field. You can use Autodesk Construction Cloud as part of a connected source of truth, so that whether you're needing to integrate files or cost data or imagery or budgets or change orders or whatever it is that you may be using, you can do so with our set of APIs with ACC Connect that I'll get into here in a second. Okay, so when we refer to ACC Connect, again, Autodesk Construction Cloud Connect, it's an integration platform as a service that's powered by Workato. It allows you to go and build your own custom workflows between Autodesk Construction Cloud and other tools out there. For example, SharePoint or Ignite, or maybe it's business intelligence tools such as Power BI, project management tools such as Asana, Airtable, and Smartsheet. You can use ACC Connect, and it sits in between those platforms and Autodesk Construction Cloud. And you can build your own drag and drop workflows, as you see here on the left-hand side of the screen, to route the data or the files that match your own processes, so that you can move files or analyze different trends that are happening within your issues or RFIs, and so forth. We have connectors to all of the Autodesk Construction Cloud products. If you're not familiar with Autodesk Construction Cloud and the products associated with it, when we refer to Autodesk Construction Cloud, that's a suite of products that we're delivering to construction teams. So there's Autodesk BIM Collaborate, which is used by design teams in particular to condition their models. Autodesk Takeoff, which is used to get the quantities from the 2D sheets or 3D models that exist inside of Autodesk Construction Cloud. And then Autodesk Build, which is primarily used during the construction phase of any sort of project and has all those 3D models, those 2D sheets, but everything else that you may need for the job site or for the project, that is your issues, RFIs, your budget, change orders, and so forth. All of this is underpinned by Autodesk Docs. It's a common data environment behind all of Autodesk Construction Cloud. And for the purpose of ACC Connect, that's actually really important to understand, because when you say integrate with a cloud storage provider like a SharePoint or Ignite or Box or Dropbox, and you're sending files into Autodesk Docs, those files can then be used and leveraged within different aspects of Autodesk Construction Cloud. So regardless if it's Takeoff or BIM Collaborate or Build, the files, say a model or your drawings or your design documents that are stored within Docs, can be used inside the entire unified platform. Okay, so I touched on this just a few moments ago, but a couple common use cases that we see out there with Autodesk Construction Cloud Connect: document management and project management. So we support integrations with SharePoint, Ignite, Box, and so forth. On the project management side, you're able to extract out the issues or RFIs, or maybe even its cost management data, and have that available within, say, Smartsheet or Airtable or Asana or Power BI. Really common workflow, especially with Smartsheet, is to extract out all the data from the issues and then organize them in your own way inside Smartsheet. So have rows and columns and whatnot, everything that comes from Autodesk Construction Cloud. It's bidirectional. So if you were to update something, or you can build it bidirectionally. So if you were to update something in Smartsheet, for example, that can reflect back over into Autodesk Construction Cloud, say the status of an issue, or who it's assigned to, or the description, or so forth of it. But the most common use case that we have, and the number one use case, is certainly around cloud storage. And again, it's a bidirectional workflow. ACC Connect sits in between ACC and third-party tool, and allows you to bidirectionally sync documents, models, sheets, forms, photos. Really anything and everything between the two platforms. Great example here is working with Ignite or SharePoint. Design teams are working inside of these cloud storage providers, and they're working on their drawings or their maybe they have some sort of contracts and whatnot that they're working on there. ACC Connect can detect upload a particular folder if you're using a particular folder to manage these design documents, and then transfer it into the relevant project folders within Autodesk Construction Cloud so that teams in the field have access to these design documents, drawings, contracts, the models, and so forth to work on in the field. Conversely, when you're in Autodesk Build and you're creating different inspection forms or creating different documents within docs, ACC Connect can check for completed forms that are now available or have been submitted inside Autodesk Build and back them up into the corresponding folder within SharePoint or Ignite. So team members who are in the office or maybe it's part of the broader organization have access and purview into what's going on in the field. So with that, I'm really happy to welcome David we'll talk about a real world example.
Thanks, Jeremy. Hi, everyone. My name is David Mack, and I'm a construction technology manager with the Walsh Group, and I'm going to be talking through a real world example of the ACC Connect application today. So if you're not familiar with the Walsh Group, we're one of the largest general contractors in the US. We focus on 3 key business markets, that being building, transportation, and water markets. We have 21 offices around the US and roughly 8,000 employees doing 7.6 billion in annual revenue. And this case study specifically focuses on a project that we completed in Nashville, Tennessee. And it consisted of 2 mixed-use multifamily buildings totaling over 650 units. Our field team had begun the project using PlanGrid for all document control, including RFIs, submittals, punch list tracking, basically everything. But we had also set up a BIM 360 site that we had used to collaborate with our subcontractors during BIM coordination. We used it to host the construction models on. Our field team enjoyed the user interface and like the overall functionality of BIM 360 over PlanGrid, and they liked that subcontractors didn't need their own licenses to access the site just based on how our enterprise agreement works with Autodesk. So that was really nice, especially when it came to closing out punch list items. We didn't need to get every licenses for all of our subcontractors to get on the site and be able to close out their issues. So the team decided that moving forward, they wanted all punch list tracking to be done through BIM 360 and reached out to me to see if there was a way to migrate their existing PlanGrid tasks to create BIM 360 issues, essentially just move everything over to the new platform. Unfortunately, there was no out-of-the-box solution to do this, and since there were roughly 2,500 existing tasks in PlanGrid, manually creating duplicate issues in BIM 360 would have taken hundreds of man-hours, and there's really no efficient way to prevent user input errors on those 2,500 tasks. So we reached out to our partners at Autodesk to discuss potential solutions on what we could do, how we could optimize that. They pointed us towards ACC Connect, which offers, like Jeremy mentioned, a low-code option to create custom workflows between construction management platforms and other platforms as well. But we're going to be talking about construction management platforms today. It seemed like a great solution that met all of our needs for the project. And once we began utilizing ACC Connect, though, we quickly ran into our next roadblock, which was ACC Connect does offer PlanGrid connectors to move items over from PlanGrid to other places, but it lacked the functionality to read all of the existing tasks with the out-of-the-box connector. So this is where we began to call those existing web APIs for PlanGrid. The APIs assisted us in reading the tasks, and we were able to use the built-in BIM 360 connector to create these tasks as issues on the BIM 360 site. And it's important to realize too that this recipe that we're going to be talking about isn't really exclusive to BIM 360. That's just our use case for it. You can apply the same logic to migrate items to ACC as well. And it can really be extrapolated towards a lot of other things on ACC and BIM 360, not just issues. So it's pretty adaptable, I'd say. And as I mentioned before, this saved us hundreds of man hours of manually creating issues on the site, transferring them over, making sure there are no, input errors or anything like that. And after a few development meetings and some testing, we were able to successfully transfer all of the PlanGrid tasks to BIM 360 so that our field team had a complete list of all the punch list items on the project. The team was then able to successfully execute the remainder of the punch list and the project all on one platform, so they didn't have to jump back and forth between BIM 360 and PlanGrid, printing out different reports, turning them over to the owner, trying to consolidate them. Was much easier once we got it all on one platform. So that's kind of what this slide discusses, just ACC connecting the bridge between PlanGrid and BIM 360. And this can be used as well to, if you wanted to automate that recipe, to kind of, if you had a team continually creating tasks in PlanGrid, you could run this on a schedule and have things transferred over to BIM 360 daily or weekly or however often you want to run it as well. So as for the specific recipe, I'm going to go through the individual steps that we created. You get the projects in PlanGrid, like I mentioned, and then you kind of loop through all the pages to get to all the projects that you have access to. You loop through each project, and then you stop the job if there are no remaining tasks. You're monitoring for errors throughout the whole course of the project as well, getting the tasks in the PlanGrid project, and then retrying that if there's some internal error, or if it'll try it a couple times just to make sure that that error persists, and it'll log a message too if that error, if there is an error. That's then checking to see if there are available tasks, and it processes each PlanGrid task, and it proceeds only if the task still exists, if it hasn't been deleted. So it'll then create the BIM 360 issue, which we can do with the built-in BIM 360 connector. And then there's a waiting time there to make sure that the rate limit for accessing that isn't exceeded. So then it'll log the error at the end as well, just to make sure that you're capturing anything that may go wrong. So I'm going to hand it back over now to Amit to discuss the features of ACC Connect.
Thanks, David. And by now you'd have seen how easily you can create an automated workflow in ACC Connect. And it provides all the different elements that you need to create an automated workflow. In the next section, I'll try to cover some of the ACC Connect features which enable you in creating an automated workflow. So I'll try to cover through the slide deck and demo video so that you realize the potential of these important and powerful features. So custom actions in connectors. Now, not all the functionalities that you're looking for, it may be available through the connectors which are available in ACC Connect, because we have a ever updating set of APIs that keeps adding new set of APIs every month or every quarter. So how you can utilize the custom actions which are available in these connectors so that you can directly make API calls to Autodesk platform services without handling the tokens, which you normally require when you're making an API call. So the configuration process is really easy, and let me take you through a quick video to show you how does that work. So when you come over to creating a new recipe, you just type in the name and you start building that. Now I'll come over to the trigger option and I'll select a trigger for Autodesk Construction Cloud. I'll select the connection and I'll select the event. So I'm selecting new or updated event in a project or new or updated document. I'm selecting the project name, the folder name, and the account name. The next step that I'm doing is to create a custom action. So I'm looking for a functionality to get custom attributes. And we do not have such a functionality available by default in the connector. So I'm adding a custom action, and let's have a quick look at the API documentation. So you can see there is an endpoint which shows how you can make a call to the API so that you can get the custom attribute definitions. So there are different headers, there are different parameters like project ID and folder ID, which is an input, and there are limit and offsets. So these are some optional parameters. At the bottom, you see the result structure and the body structure, sorry, the request structure and the response structure. So the verb, the HTTP verb is get. I mean, it is a read-only request, so it is called get. So we have all this information available in the documentation. We just need to replicate it within ACC Connect. So we just copy the different elements here, you can see, and we need to replace the project ID and the folder ID. So how do we use the project ID and the folder ID? We'll be using the data pills here. So data pills are like variables in ACC Connect, and you can see we are getting the project ID from step 1 when it is triggering a new or updated document, and we are getting the folder ID. So we are passing all the project ID and the folder ID. And next step is to save it and test it out. Now it is looking for a trigger event, and what we'll do is we'll go over to ACC and upload a file here. Now, as soon as you've uploaded a file, it will trigger the event and it will start returning the results. So it will get the project ID, the folder ID of the document where it was uploaded, and it will use that project ID and folder ID to make the API call. And here you can see we are getting the custom attribute definitions. So we are getting the different custom attributes which were defined. And you could also send out an email confirming or sending out the details of the API call that we saw just now. So we are adding a subject saying, what was the file name? Because we are getting that from the step 1 whenever a new or updated document is triggered. And we are providing the message saying, what are the different elements which constitute the body? So we can configure all of those changes, and you can see all of that change or all of that data is available in the API call. The next thing what we are doing is defining a structure of the result. So what we saw just now is that the data was not easily accessible through the data pills because the structure was not defined. So we defined the structure, and now when you expand the body, you'll see the data pills coming over. So we need the ID, we need the name, and we need the type of the custom attribute. And that all detail comes over as data pill. So this is how you can create or leverage the custom actions and connectors to make API calls to Autodesk Platform Services. Now, moving on to the next important functionality is not all the times you'll need to connect to Autodesk Platform Services. You'll need to connect to third-party API platforms as well. So the HTTP connector offers universal API access for applications without pre-built connectors. So you can make HTTP requests to any other API endpoint for which we have the publicly available APIs. And this provides more flexibility than the specified or the specific services which are offered by pre-built connectors. You can control the amount of data that you're receiving at this stage, and you can also control the different data structure by specifying all that detail in the connector. So here on the right-hand side, you see how you can set up a HTTP connection. Let me take you through a quick video where I'll show you how you can quickly set up a HTTP connection and then leverage the HTTP connector. So I'm clicking on new connection and I'm clicking on HTTP. I give it a name. So it is a one-time action. We need to create the setup. We need to set up the connection for the first time. And we can specify the authentication type. So it supports all the major authentication types which are provided by different API platforms. We have basic, we have OAuth 2, which is one of the most popular ones and adopted ones. And we have authorization code grant, which is the 3-legged, and the user and the client credentials grant, which is the 2-legged token. So for now, we'll go ahead with the 2-legged option, We'll need to provide the token URL. Now, all of these details are provided in the documentation. So you don't need to remember anything, or it's not a complex job. You just need to copy and paste the different elements, and you need to bring it in the connection. I provided my client ID, and I need to provide my client secret. And how are you trying to pass the request token? All of that is specified, and then you specify the authentication scope. So we are taking a universal scope as of now, and I'll click on connect. Now, as soon as you do that, it has automatically created a connection. And now we are good to go. Now we can leverage the HTTP connector. So I'll go ahead with the recipe creation. I'll give a name to it. And let's move ahead. We have selected the trigger based on the time option, and we'll bring in the HTTP connector. Now here we'll select the connection that we just created. And we are trying to use the same example. We are trying to get the custom attributes. This time we are not going with the custom option. Instead, we are using the more generic option, that is the HTTP connector. So the process is very similar. You can see the UI is very similar. You see the wizard open up, and it specifies what is the method. The method is get, because it is a read-only request. We provide the request URL and the response type. And as soon as you do that, you can see it has automatically made that API call, and it has got the sample data. And based on that sample data, it has automatically created a structure as well. Now let's see how does the structure look like. So you can see the results come over here. And if we bring in an additional connector, and we'll see how does the data look like. So I'll bring in an email connector just to show you the different database that have come over. And you can see in the step 2 output, you can see the different array values, the ID name. So you can bring in the different ID name, and these are available as a list because we are having multiple set of values. Now, what if you don't need all the different data that is coming in through the API call? Instead, you just need the ID and the name, and not the type and the other details. So what you can do is you can change the structure, and now you can see you're just receiving the ID and name. So this gives you a complete control over the amount of data that you want to move forward with the further steps. So you can reduce that amount and probably select the ones that you really need. So this offers a more customized option compared to the previous options that we have seen, or the connector options which we have seen. Now moving ahead, what are the different triggers which are available? Each connector in ACC Connect has its own set of triggers, which are based on the events which occur in that platform. To give you an example, here we are seeing a trigger based on the Autodesk Construction Cloud. So there are different types of triggers which may happen here, like new or updated document, or new issue which has been created, or similar events like that. So each connector has its specific triggers, like we discussed, and based on this, whenever this trigger is encountered, the recipe is automatically executed. So here we are seeing that when the trigger is executed, subsequent set of actions like downloading the document, that is step 2, and uploading the file into a library in SharePoint, that is step 3, those will be executed automatically. So that's how the triggers work. Now, when we are talking about inbuilt triggers, so these may already be defined within the connectors which are available in ACC Connect. However, what if there is a trigger which is not available in the connector and you'd like to leverage it? So ACC Connect provides very easy way to set this up, to set up a different webhook. Now, what are the different elements that you need when you're setting up a webhook? First, whenever you're trying to set up a webhook, you need a unique webhook address. The webhook address is used by the notifying platform so that it reaches out to you through that address. And the second thing is you need a service that keeps looking to the webhook event. So these are the two major things that you need to set up a webhook. Now, ACC Connect provides both of these very easily. First, it will provide you the unique address, and it will also keep looking for the webhook event because it is a cloud platform. So let me play a quick video to show you the capabilities of webhooks. So there are different events which are available on the APS platform. Similarly, it could be any number of events which are supported by any other platform. The process remains similar. So here you can see we have a few events like DM version added, so data management version added. Whenever a new version of a file is added, it will trigger this. So you have a body structure. How does the body look like when it is returned? The result is returned. And how does the response look like? So how do we start or set up a webhook? So we'll click on create folder. We'll just create a separate folder for now, and we'll click on create recipe. Now, as soon as you do that, there are different options which you are normally getting. In this time, we'll select trigger from webhook, third option. And we'll start with start guided setup. So this is like a wizard option, which guides you through all the different steps. So I'll say dm.version added. And as we move next, you see we get a unique URL that can be used to set up the webhook. So we have copied this. And the next step would be to set up the webhook in a neutral environment like Postman. So what we can do is we can define the webhook so that whenever there is a new file or new version added to a particular folder, it will let us know or it will notify us. So I've created a sample folder and I'll mention the folder ID here, and I'll also add the project ID. So we need two inputs. We need the folder ID and the project ID. So I'm using Postman. It is a very simple tool, very simple steps. We get the folder ID and the project ID from these API calls, and we'll just use it to make the API call to set it up. Okay, so once I've done, I'll send this request now. I'll copy the URL that we are getting from ACC Connect. Now, once you send that, you see 201 created. That is the status message, which implies that the webhook has been set up. But still, you see that ACC Connect is still waiting for the event to occur. We have defined the event, but we need to run the event. So let me copy a dummy document here to that folder, and we'll see that the event will be triggered automatically now. So now we can see that the event has been triggered, and it is returning the data associated with the file which has been uploaded. So it is returning the file name, the size, who has uploaded that, the project name, all of that information. And when you set it up, you can see that it has also automatically created the schema. So the schema is really helpful because it automatically defines the variables which are being provided by the webhook. And you can see all of those variables here. So you can see the name, the creator, all of that, and you can use it in subsequent steps. So this is very easy to set up a webhook, even if you do not have it defined within the connector, and you can readily do that. So that was a quick overview of webhooks. ACC Connect also provides robust looping capabilities to manage the data within the recipes, because you'll need to filter out, you need to run different iterations, and all of that is easily provided. So here you can see we have an example on the right hand side. So for each item in a particular step, repeat the following steps. Also, you can see there is monitor block. If there is error found, retry. If error persists, log a message. So there are different conditions and error handling steps. Now moving on to the next part, which is the recipe functions. So what are recipe functions? So the recipe functions can be considered analogous to functions which we have for different coding environments. So what is a function, or what is a recipe function? They can be used to create a collection of repeatable step of actions or repeatable set of actions into recipes, which you can reuse for other recipes. The advantage is that you can build it once and reuse anywhere. It reduces your testing efforts because you're confident that these set of codes are perfectly written and we do not need to go through the testing for these statements again. And it increases the recipe readability because you don't have all these lines repeated or all these steps repeated everywhere in all the recipes. So on the right hand side, you see the rest. How does the recipe function look like? So you have a trigger, and there are a set of actions, very similar to how you have a recipe. So let me run a quick video to show how does the recipe function look like and how is it declared. So we have defined a recipe function and we have provided the schema. So the schema is the input data that you receive. So here you can see we have defined the schema. Based on that, it automatically understands what is the input that it should be looking at. And once you have specified that, you'll see that it is automatically populating that as data pills. And what is the return type? So what is the data that you'll be returning? So we're making an API call here similar to what we did earlier. We are making calls to the APS APIs to get custom attributes, and we are getting the ID, name, and type as the output type. So you can see the schema here. And so all the schema can be automatically got from the documentation. So currently we are reducing the schema size to just include the limited set of results instead of bringing in all the information. We have set ID, name, and type. And we're using the project ID and the folder ID as the inputs coming in from step one, because we want to make the API call to get the custom attribute definition for a particular folder in a particular project. So we have specified all these variables. And next, when the API call is successful, we'll get the results list and we'll get the ID, name, and type, which will return to the calling recipe or the main recipe. Now, one thing to note here is we have started this recipe. So starting this recipe means that it will remain active and it will keep looking for any API calls or any calls that are made to it. Now I've created a parent recipe that will call this child recipe or the recipe function. And there are two options here, synchronous and asynchronous. Synchronous means that it will wait for the recipe function to complete and return the result before proceeding to the next step. In asynchronous, it does not wait for the recipe function. Instead, it will continue with the rest of the execution. So for now, we'll select the synchronous option. And as soon as we do that, it will ask us to select the recipe function that we are looking at. So I've selected the recipe function, and as soon as I select that, it will automatically list in the different inputs that I need. I need the project ID and the folder ID. And for now, I'll just hard code the project ID and the folder ID. But if we are having an actual recipe, we'll be getting that as variables. So we have provided the folder ID and the project ID, and we'll save it. Now, from the main recipe, we are calling the recipe function, and you can see we are getting the results automatically. So we're getting the ID, we're getting the name, and we're getting the type. And one thing to note here is that if you move forward with the recipe ahead, I mean, after this step, you get all the data available in database. So you don't need to create a structure because the structure will automatically come in from the recipe function. So here you can see ID, name, and type coming in from the recipe function. So that was a quick overview of how does a recipe function work. The next part is around error handling. Now, whenever you're developing or writing an automated script, you need to have a robust error handling structure or error handling strategy in place, because you may come across or your script may come across some errors during its execution, and it is important to monitor what has gone wrong. So the error monitoring steps in ACC Connect, they verify the action completion and enable retrying or proceeding to the next step if errors happen. So we have multiple ways of doing that. We have conditional actions, if conditions, which help you validate the input data. You also have stop actions using which you can stop the further processing of the job so that you do not impact the further set of actions which are available in the recipes. So here you have a trigger, and you can see there are monitor blocks, and if there is error found, we have retry, and if error persists, there is a set of action. So let me take you through a quick video to show you how does this work. So we have created a we'll create a new recipe here and we'll start building that. Now here you can see stop job and handle error. So when you click on handle error, it will automatically bring in the action, that is the monitor block, which monitors a set of steps which are included within the monitor block. Now, if any of these steps fail, it will pass on to error found step. So you can see for now, I'm just bringing in a sample step, which is send email, and probably another step here, anything in Autodesk Construction Cloud, like searching for an object or something like that. Now, if there is something wrong with these particular steps, it will go to error found. And in error found, you'll find there are retry options which are available. Now, what if it was a network error and you want to retry it? So there are maximum of 3 different number of times you can retry, and you can also specify the interval between each retries up to a maximum of 10 seconds. And you can also filter, do you want to retry only if a particular error code has happened or a particular message has been returned by the server? So that all different filters you can specify. Now, what if the error is still persisting? Even then you need to take corrective actions, right? So in that case, we have an option where probably you can send out an email, or you can probably log it in the logger. So there are different steps which you can perform if the error still persists. So you have all the fail-safe mechanisms in place so that you do not skip out an error that may have been encountered when this recipe was executed. So that is how the error handling works in ACC Connect. Now moving on to the next part, which is loggers and lookup tables. So the logger service or the logging service provides centralized storage for collecting and searching through the different log entries. And what are the different use cases? When you're running loops in recipes, you do not get the data for each particular step of the loop. You only get the data for the last step. So this can really help you in investigating the data that is coming from the loops. And the other part is analyzing the data for debugging the multiple recipes. So if you have the log data available, you can probably have a look and see what is going wrong with the execution of a particular recipe. So that is how the logger works. And we also have an option called lookup table. So lookup table can be considered as a reference table, which can be used to define or use these reference tables to generate new set of values, or probably create a referencing match. You can do that. So the lookup tables enable recipes to efficiently store, reference, and manage frequently used data using a table of entry rows and value columns, similar to a cross-reference table. Now, let me show you a quick video showing how you can use the lookup tables and the logger. So here we have a lookup table that contains 2 set of columns, ID and value. And what we'll do is we'll try to update these values using the recipe. So I'll create a new folder for now. And we'll be using the same function that we had created some time back. And I'll create a new recipe, a parent recipe that will call this recipe function. I'll make the call to the API or to the recipe function. I'll provide the project ID, the folder ID. And the return, what is the return that I expect? That should be a list that should contain ID, name, type, all these attributes. Now what I'll do is I'll populate the ID and the name to the lookup table. So I'm running a loop for each of these values. I want to update these values in the lookup table. So here you can see I'm adding add entry. I select my lookup table and it automatically brings in the column names. So I select the ID from here. I select the value, that is the name from here, and I save it and run it. Now you can see it will automatically populate the values. Let me refresh and you see these values, ID and value, available in the lookup table. And then I can also add a log. So moving on to the logger, you can see I can also add a message to check what is the output at each level of the loop iteration. So here I'm adding the ID, I'm adding the name, and I'll add the type and the iteration count, the loop iteration count. So here you can see the count as well, the index, and then I'll save and test it out. You can also send it to the Workato log service, or you can just save it to run or to show the results in your logs when you're testing it out. You can specify the log level. Should it be info? Should it be warning? And when you test it out, in the results, you only see the last value, the last set of value, which was a part of the last execution. But if you go to the logger and you search for all the results, you'll see we have three different entries. Loop iteration 0, loop iteration 1, loop iteration 2, based on the different indexes. So this is how you can use loggers and lookup tables to achieve automated workflows and to handle errors better. The next element is the operations hub. So the operations hub can be considered as a dashboard that allows users to visualize the real-time data pertaining to the recipes and connections in the account. So here you can see a summary of the number of recipes which are running, the number of successful jobs, failed jobs, and the tasks used. Now you can drill down to the ones which are failing, and you can go into deep dive into those test data to see what is the corrective action that you need to perform. With that, I'll come back to the original slide again. So I talked about what are the ingredient automation platform which will make your task easier in creating an automated workflow. So we talked about integration capabilities. So we saw there were 400 plus integrations which are available within ACC Connect. In terms of workflow management, we have easier recipe functions which help you to automate workflows by reducing your code to smaller condensed set of steps. We have a no-code user interface which is supported by ACC Connect. We have the security features implemented by the secured connections which are authenticated. Being a cloud platform, we have high scalability. We saw the operations hub using which you have the reporting and analytics available within this platform. We saw very robust error handling capabilities by the monitor and repeat blocks. We also saw a lot of customization options because we have a no-code UI where it is easy to drag and drop. So it is really easy to customize. We have API access available through the different HTTP connectors and custom actions. And there is elaborate set of documentation and support available. So these are the different capabilities which make ACC Connect a very powerful platform and automating a workflow even for people who are not coders. Now, some of the practical other use cases which you can also look upon, automating the project creation in ACC and automating the project user management. You can leverage the APIs to create an automated workflow for this. We saw the custom attributes. Now we just talked about getting the custom attribute definition, getting the custom attributes, but it could be a wider workflow where you can report the custom attributes in an external file like Excel. You can also use that same Excel sheet to update the custom attributes based on the data that is entered by the user. So these are some of the other practical use cases which you can also leverage by leveraging the set of APIs. And that does not limit you there. You can definitely connect to third-party platforms through the set of functionalities that we talked about. So the possibilities are limitless. So that's all that we had to cover for today's session. Thank you for listening to us.